Welcome to our webcast. This is actually fun. Got a lot of people on board. This is sort of like the old user group meetings we used to do, but it's a virtual user group. And I'd like to welcome everybody to the webcast. I'm Lester Knutsen, and this is part of a series that we're doing. A couple of guidelines. The webcast is being recorded, and we should have the slides and the webcast available in a few days. As a consideration to everybody else, if you could keep yourself on mute, because the background noise will distract everyone and make it more difficult to hear. If you have questions, find the chat button and put your questions in the chat, and I will get to them. I may not answer them right away. I want to point out that when I go full screen like this, I don't see the chat. So if the slides are full screen like this, I'm probably not going to see the chat, but I will get to it. I'm saving time at the end of the webcast for the chat. Now, this one is the third in a series of free Informix tutorials we're doing. And this is on managing Informix disk space. And I'm going to start out with a demo here in just a minute on the new way of managing disk space, and that's to get Informix HQ. This is one of the best things out, and in the latest version of 12, it is actually included. So the version of 12 that just came out last week, I believe it was, includes Informix HQ. It does work with version 12. So one reason to get version 14, even if you don't upgrade, is you can use the Informix HQ that comes with 14 with 12. Then I'll talk about storage, the types of storage, SANs. I'll talk about RAID. There's a lot of good information from my colleague, Art Cagle here on the dangers of RAID 5. And then we'll talk about the Informix storage pool and best practices, how to monitor your disk space, and we'll end up with another demo. So let me dive right into using Informix HQ to manage your DB spaces. One of the things you can do with Informix HQ is set up a pool. And the pool is an area of disk, and it could be one big raw chunk. It could be a directory, which is what I have done here. I've created a directory, and I've said, okay, this directory is where you can take space from when you need it. I'm going to just, as an example, add another directory, and this is going to be another, let me give it a different name, Informix chunks, new server 3. And I'm going to say that it's expandable. And the chunk size by default, I'm going to make it 1 gig, so that anytime it creates a chunk, it will be 1 gig by default. Oh, path does not exist. It didn't like that. It has to be a valid path. Let me go back and see what's wrong with that. Informix chunks, Informix server 2. That's right. Oh, I know. I've already used it. Can't do that. I've already used that. I can't give it the same path as I have here. Anyway, once I've done that, I can come over here and say, create a new chunk. And I'm going to call this new DBS. It's a DB space. I'm going to make it, let's just make it 2 gigs. Default page size. And I'm going to say, take the space from the storage pool and make it expandable. What this make it expandable means is when I fill up that 2 gig space, it's going to automatically expand it. I'm going to hit create. It goes off and creates it. And I'll get a message here saying it's been created. Let me go to the last page here, and we should see it in just a minute. And if I come down here to the right server, and I do an onstat minus D more, I see my new DB space there, and you can see where it created that new DB space. So this is one of the cool new features in 14 and the latest versions of 12 is you can use this GUI to easily add chunks and spaces to it. You can take an existing DB space and add chunks to it if you need to. You can do all kinds of wonderful things. So let's talk about the types of data storage and dive into the underlying things here, because even though that makes Informix HQ makes it easy, you still need to plan and know what's going on behind the scenes. We had a client a couple of years ago when storage pools came out. They said, "Oh, we don't need any help. We'll create a storage pool." Worked great for a year. After a year, they filled up the disk drive completely, and it hung their server. And it still takes monitoring. You still have to know how things are going on, what's going on in the background for this to work. Now, there are three types of data storage devices. There's solid state SSD drives, there's spinning disk drives, and then there's SANs. And I'm going to talk briefly about all three. A spinning disk is a platter, and you have a disk arm. And because that disk arm can only be at one place at one time, you can only read from one place on the disk at a time. That's why things like fragmentation were very important. Where the arm was extremely important. Every disk drive had a fastest location on disk. Most of the time it was in the middle. And that meant the arm could get from the left edge to there faster than any other place, and from the center to there faster than any other place. So that was the best place to put your data if you had a spinning disk drive. And you could partition a disk. You had to do it at the partition level to identify where that was. And do it. And I used to spend hours doing this with databases to make them very fast. Solid state disk drives have changed that, because with a solid state disk drive, you have an array of memory cells that equally can be accessed just as fast as any other memory cell on that solid array. So fragmentation is not as important as it used to be. Think of a solid state disk drive as a bunch of chips, and you can address the memory on any one of those chips just as fast as any other chip. Now, SSD drives do some other things. There are no moving parts, but what they typically do is they don't do updates. If you change a page or a block, instead of updating the old page, it writes it to a new page and changes the address to that page. And then in the background, later on, it goes out and marks that old page as now freed and can be reused. This is something to keep in mind with solid state disk drives. They do have a limit of how many times a cell or a part of memory can get updated. But they're reliable. When they first came out, everybody was afraid that they weren't going to be reliable. I've had solid state disk drives in machines now for 8 years, and I've not had any problems with them. Now the performance does vary by manufacturer. The interesting thing I've found with solid state disk drives, the larger drives are faster. And that's usually because you have more cells there. You can spread the data out more, and it's just faster to retrieve it. I bought a bunch of cheap 128 meg drives. I thought they'd be great for my training machines. They were so slow, I haven't used them. 2 gig solid state disk drives are sort of what I think is the best spot. And they'll easily be 3 times faster than the hard disk on the same machine. Now, you want to look at SSD drive interfaces. There's an interface called M.2, which plugs directly into the motherboard of your computer. And that will be way faster than a regular SSD drive plugging into a SATA controller. So anytime, the fastest drives I've benchmarked have been internal drives using the M.2 interface. Fusion drives are a combination of spinning disk and SSD drive. And they're great for demos, but once your active data set, that is the data you use, exceeds the size of the cache, and the cache is what's on the SSD drive, they don't work. They also take extra CPU cycles to sync that cache with your disk, because what you do is you write to the SSD drive, and then in the background, it writes it out to disk. Might as well have a bigger cache in memory on your computer and let the computer do that. So I basically think fusion drives are a waste of time. But I do know people are using them. Now, SANs. This is where everybody is going with data storage. And the good part and the bad part of SANs is, as a DBA, you don't have to know what they are. The bad part is you don't know what they are. You need a SAN administrator. And so one thing I always tell people, SANs are great. You need to pay for a good SAN administrator. And just like it's hard to find a good DBA, it's hard to find a good SAN administrator because they have to know the internals of how that SAN works to actually get the best performance. There are a lot of things to do with SANs. A SAN includes switches that access, it's not just disk, it's the storage array, it's the switches, it's how devices are interconnected to it. But everybody's doing that. It's the old days of you used to be a DBA and the sysadmin and the storage administrator are gone. Everybody has SANs and that's the way to go. So the key thing is you need to have very realistic benchmarks when you move to a SAN so that you can tell whether your SAN is performing or not. And SAN vendors are very good at hiding performance, real performance data from you. You need to be upfront with them and tell them how many KB per minute access do you need to that SAN, and monitor that and make sure you're getting that from the SAN. One of my favorite stories about SAN is, and this is, SANs have been around for a while. This was about 8 or 9 years ago. I was working with a client. I had been monitoring their system for about 4 years. So we had 4 years of good disk IO information. And we weren't actively monitoring it anymore, but then they called up one day and said, our performance has really gone bad. And I went back and looked at my monitoring data and I said, okay, it was monitoring great. And then I gave them the date, April 12th this year, your IO performance went down. Go ask your SAN administrator what happened. And sure enough, they went to the SAN administrator. The first answer was, oh, nothing happened. But performance was so bad, it got escalated, and it turned out there had been a SAN upgrade on that day. And the SAN administrators had not realized that that upgrade had caused a performance problem. So you got to monitor your storage very carefully. The other thing to realize with disk drives is the interface between the disk and the computer is very important. Back in the old days, we all used to use SCSI disk as the interface. And then came SATA disk. And I still think these are very good SAS, serial attached SCSI adapters. We have one server at the office that has 12 disks connected in RAID 10 and SAS, and that's some of the best throughput I have seen. Then you have Fibre Channel, and most SANs are connected with some kind of Fibre Channel, and they range from 32 to 128 gigabits per second. This is on a very high speed network. And so you can see from the 12 gigabits per second to 32 to 128 gigabits per second, that's quite a big improvement. The thing you got to realize with Fibre Channel is your host, your database server is not the only thing using that. Whereas this 12 gigs per second, your database server may have been the only thing using it. This 120 gigabits per second may have 20 other servers using that. And so your database server is not going to get 128 gigabits per second. You'll get 1/20th of that. The other interesting technology that I really like for small computers is Thunderbolt. This is an interface developed by Intel and Apple. You can get it on Linux systems now. You can get it on Windows systems. It does 40 gigs per second, and it's very fast. It's for an individual computer. Some of the fastest disk arrays I've benchmarked have been Thunderbolt arrays on my Apple computers. So the key to best performance is to have a lot of disk and have a very fast interface that connects you to your database server. That in a nutshell is what you're looking at, is how many disks do you have? If they're SSD disks, they're better and more. A lot of SSD big drives are the best, at least 2 gig. They're now coming out with 4 and 8 gig SSD drives, which I think would be really good. And have a lot of them and a very fast interface like Fibre Channel or Thunderbolt connected to your computer. So once you've got the hardware in place, the next layer is what is the software that is going to control that disk array? And this is where RAID comes in. RAID is the software, and it can be at the hardware level. And even though there's a lot of people that say our RAID is at the hardware, it's software running on top of that hardware. It's a RAID stands for Redundant Array of Independent Disk. And the goal here is to improve performance, reliability, and safety of your data on a bunch of disk. So it's to take this bunch of disk and manage it as a group to improve the performance, reliability, and safety. Now, there are 4 types of RAID I'm going to talk about. RAID 1 is the safest. This is an exact copy of your data on 2 or more disks. It could be 3, it could be 4 disks. If one disk fails, everything will keep going. You may not even notice it. I had a client, I like to tell this story. I was visiting them, it had been a month since I'd been out there. And I did an onstat -D, just like this. And it was scrolling off the screen because they had like, I don't know, 400 or 500 chunks. And I just happened to notice that one of these flags said D, which means down. And I stopped it and I said, whoa, what's wrong with that? They had had one chunk that had been down for about a month, but no one had noticed it because they actually had RAID 10, but it was the same effect as RAID 1. Because there's an exact copy of the data, no one noticed it. This is the safest version of RAID you can get. RAID 0 is the fastest. And what it does is it takes your data and stripes it across 2 or more disks. If you have a RAID 0 array with 6 disks, you're going to read data 6 times faster than off of 1 disk, because the data is going to be striped across all 6 disks, and therefore you can read, and it depends on how many disks you have in a RAID 0 array, that many times faster. So this is very fast, and this is the way to get performance. Now, RAID 10 takes RAID 1 and RAID 0 and combines it, and it's the safest and the fastest. So here you take the mirroring of RAID 1 and combine it with the striping of RAID 0. You get the best performance, the best reliability, the safest. If one disk goes down, you can keep going and you won't even notice it. And this won't even notice it is key when I start talking about RAID 5 in just a minute. Now, the one thing here is with databases, a smaller stripe size of 64 or 128K is the recommended configuration, but this is the most reliable. The biggest problem with RAID 10 is not when a disk fails, but when your actual interface fails to the disk. And that's a problem with any RAID system. Here's an example of a RAID 10 array. I have 6 disks, 3 disks, and the data is striped across all 3 disks. So it can read from 3 disks all at once, but because the disk is mirrored, it can read from the other 3 at the same time. So reads are going to be 6 times faster than normal because of this configuration. Writes are going to be about the same. Well, actually it'll be 3 times faster because it can write to all 3 at the same time. It'll write a strip across all 3. This is the best performance. And you want to think about, again, 128 stripe size is probably best for databases. Don't do a big stripe size. That's okay for file systems. It's not okay for databases. Now, RAID 5, 6, and 7, they're dangerous. And I'm going to just tell you my experience with a couple of sites. I have sites that use them and they work. I've also had sites that use them. If one disk crashes, the disk has to get rebuilt. And that rebuilt is not automatically. With RAID 0, it can keep reading from the primary drive. There is nothing to rebuild. With RAID 5, 6, 7, if one disk crashes, it has to be rebuilt. And that's what causes the problem. Is Informix is going to say, oops, I can't read data because it's being rebuilt, so I'm going to mark this chunk as down. And when that happens, you end up having to restore. The other thing about RAIDs 5, 6, 7 is they all use a calculation to write the data, a checksum calculation. And that may be slow. And if that checksum calculation is wrong, you may get corrupt data. So Art has a number of good presentations on this. I'm not going to label this, but point you to Art's presentations on RAID 5, 6, and 7. Just don't use them. And I have clients who say they have to use them. Salespeople like them because they can sell you more disk at a cheaper price. Now, disk drives will fail. Art, this is from Art. He found some information about CERN and their testing of disk drives and their failure rates. Disk drives will fail over time. And my actual theory is the bigger the disk drive for spinning disks, the more likely it is to fail. And then when it fails, you're now losing 2 gigs, 4 gigs, 6 gigs of data. That's a lot of data you're suddenly losing. Uh, so CERN did a bunch of testing. It's going to be in the slides. I'll leave this for you guys to read on your own. I want to point out a second site. I've been using Backblaze now for a couple of years for storage. I have about 16 terabytes I store at Backblaze. It's an online backup system. They don't do Informix, but they do files. And so if you store your data in cooked files, it automatically copies it to their site in the background. And their average 1-year failure rate, they have a great article here on drive stats, is about 1.89%. So that's almost 2%. So 100 drives, 2 will fail in a year, to think about it that way. The average life of a drive is 50 months. I like to say 4 years. About every 4 years, you need to plan to replace your disk drives. They will fail over time. It's not like something you can just keep there and they will last forever. They will fail over time. So now let's talk about raw versus cooked space. Let me just stop and just make sure, see if there are any questions. Yeah, there is no call-in number. I'm sorry about that. WebEx gets super expensive when you have call-in numbers. And you do need to use an audio. And if there are any audio problems, I meant to say this at the beginning. Yesterday I did a WebEx and some of my customers, I couldn't hear them. They could hear me fine. But afterwards I was talking with some other friends and they said, WebEx, because everybody's working from home, seems to be overloaded. So I apologize for that. And if the audio doesn't work right, the replay will be available early next week, so you can catch up on it then. Okay, so let me dive into raw versus cooked. Back in the old days, raw was the best way to set up Informix. It was 25% faster. Informix had direct access to the disk, and it didn't go through the operating system. So that made it faster, and it also made it safer because when Informix wrote to the disk and the disk said okay, if it was a raw disk, Informix knew that okay was from the hardware. If it was a cooked file and Informix wrote to the cooked file said okay, that just meant it was in the cooked files buffer. But everybody does cooked files nowadays, and cooked files have overcome that buffer problem. They do have a flag that Informix uses by default to write directly. Now, that doesn't mean that the cooked files do it. Informix opens all its cooked DB spaces with that flag turned on. The operating system can ignore it if it wants to, but most of them are pretty good about that. So the advantage to raw was Informix had direct access to the device. There's no Unix overhead, no buffering, no Unix management. It used to be 25% faster. All the systems I used to set up used to be raw, but support for it is dwindling. And I'm seeing less and less support for it. System administrators and SAN administrators say it's too hard to set up. I don't think it's actually that hard to set up. When you use a raw device, you want to use, and this is counterintuitive, you want to use the device that starts with C. Every time you create a raw device, there'll be a block version and a character version. And the character version will be really the byte version. And that's a real raw device. It'll also usually have an R as a first character in the name. This is just an example on Linux. if you go in to create a raw device, you can see here I have on SDB1 a 106 gig Linux partition that has no mount point. It is invisible, and that is my raw device. And when you create a raw device, you don't format it, you do not mount it. You then have a raw device that Informix can use. Now, the way to do it in different operating systems is slightly different. Look at your OS for specific steps. Some versions of Linux, it's getting harder to do because, again, they're taking it out, but it is there. But the good news is you can use cook space, and I've been, most of the systems I've done in the last 2 years have been on cooked space. You do access the device through the OS. There is some OS overhead, but it's very simple to manage the device. The key here is you don't want to do not use a journal file system. And that's because Informix does its own journaling. If a system administrator comes up and says, but the journal file system is safe, you say no. Informix does its own journaling. It doesn't need a journal file system. And in fact, the file system doing journaling can get confused with Informix doing journaling. So you want to avoid journaled file systems. The worst are ext2 and 3 with journaling, ZFS, BTFS. If you have JFS2, that's acceptable because you can basically treat it as a raw device. ext2 on Linux is the best for cooked devices. And you can get very fast throughput on ext2 now on Linux. Now, the way you create a cooked file manually is you go touch a device, you change the permissions, so it's read write by the user in the group and 0 for the world. Informix will not allow it if the world can read and write this. And you make sure that the owner is Informix and the group Informix only, nobody else. And then I like to create links so that I can tell where my devices are. Let me give you an example of that. On this system here, I have a directory called Informix Server, and I have a directory here called Informix Links. I also have 6 other directories, and these could be 6 separate file systems with DB spaces inside of it. And so if I look at the Informix links, I'll see here are all my DB spaces, and this tells me which directory they point to. Now, the advantage to this is if I need to, I can move one of these to a new disk drive. And all I have to do is change the link. Shut Informix down, move the cooked file to a new disk drive, recreate the link, bring Informix up, and everything is just fine. That's the advantage of links. So let's talk about Informix DB spaces, chunks, pages, and fragments. These are the guts of Informix. First thing is to take a look at your I/O. And what you'll realize is most of your writes are going to be to the physical log, the logical log, and Temp Tv Space. It's surprising what percent of your writes will be to those. I usually see 30% to the logs and maybe 50% to the Temp Tv Space and maybe 20% to the data. Every time you have a sort order by, that's going to be a read and write to your Temp Tv Space. And so most of your reads are going to be from your data and from your temp. And oftentimes they'll see 50% of the reads from temp and the rest from data. So as you can see from this, the hot disk in most cases is going to be your Temp Tv space. The hot for writes is going to be your physical and logical logs. And then your data is along with your temp is going to be hot for reads. So you want to spread your data out so that all this IO is not concentrated on the same disk drive or the same logical volume. When you're dealing with SANs, you often get things divided in logical volumes. And I like to think about, let's divide up my logical volume. So I have the logical volume for physical log, logical volume for temp, and then for data. And that gives me a spread of that data out. Now, the basics of all Informix IO is a page. You may do a select statement that asks for one character. Informix is going to read a page into the buffers. And that's because the page comes in, it goes into the buffer. And once a page is in the buffer, anything else that needs something on that page can get it from the buffer. It doesn't have to go to disk again. The same thing with writes. Informix doesn't write a byte out, it writes a page out. So all IO is in pages. As a simple example, when you do an onstat minus capital D, it shows you the IO. It's showing you the IO in pages. How many pages were read and written to each DB space. I just saw a couple of questions. I'll come back to them in just a little bit, so hang on, please. The next thing is a chunk. A chunk is the physical device. And to go back to this example here are my chunks. If you do an onstat minus D, lowercase or uppercase, it shows you the DB spaces here at the top and the chunks at the bottom. The chunks are the actual physical devices that you're reading and writing to. A DB space is a logical container of one or more chunks. And this is the way I like to think of it, is you have a DB space. Each DB space has one or more chunks. Each chunk is made up of pages. And you think of the chunk as something that gets formatted by Informix into pages. Now, every page will have a page header, and then it'll have slots for data. And there are 100 hex slots for data, or 256 byte decimal slots for data. And usually there's a 28 byte page header on a page. So when you're creating a DB space, now, and ever since version 10, you get to choose the page size for that DB space. There will be a default page size based on your operating system. And if I come back here to my onstat minus D, you can see that the default page size here is 2048 bytes. That's 2K. But you can create DB spaces with different page sizes with the onspace command. You can also do extent sizing for partitions with an EF and an EN command. And you can also make them automatically expandable, even if you don't have a storage pool. I'm going to show you how to do that in a few slides here. So what type of DB spaces do you need? The default is a normal DB space. Then you have a temporary DB space. A temporary DB space does not get backed up. It does not get logged. So think of a temporary DB space as something that gets cleared out every time you restart the Informix server. It's going to be faster because it's not logged. And it doesn't get backed up. Or really what gets backed up is an empty DB space. And every time you start Informix, it's emptied. So it's really good for your sorts and your order buys. Very important because, again, about 50% of your IO is going to be to the Temp Tv space. Then you have Blob Spaces, which is a special kind of space for storing text and bytes. And then you have unlogged and logged smart Blob Spaces, which are, again, special kinds of Blob Spaces. And then something that's new is you have a special physical log DB space. I'm going to talk about in a little bit. So first thing with chunks is you need to consider is should they be extendable? You can now create a chunk that will be extendable. And what that means is when the chunk is full, it will automatically expand. You don't need a storage pool to do this, by the way. And I'm going to show you how to do that in a few slides. It's a simple sysadmin task command to do that. You want to think about how active your chunks are going to be because that will determine where you look at them. And doing a very simple onstat minus capital T and look at the IO here. Most of my IO here has been in this data D3 DBS. I've had quite a bit of writes to my logical log too. And think about where you want to place them. And where should things be placed? On SSD drives, on fast disk, on slower disk? And should a chunk have an Informix mirror? One thing, even with RAID setup, Informix mirroring is another safety factor. And when you use Informix mirroring, Informix will then read twice as fast because it can read and it knows to read from the primary and the secondary at the same time. So if you want to make a very simple way to make your database twice as fast is use Informix mirroring and copy your data to 2 different disk drives. Now let's go through the different types of DB spaces. Excuse me, let me get a drink. The root DB space. This should be pretty much empty, except for the reserved pages, the sysmaster database, the sysutilities database, and the sysusers database. It should be the most protected DB space. If this space gets corrupt, your whole server is gone and you have to restore. So this 1 DB space is critical for safety. And because of that, you want to move the physical log, the logical log, sysadmin database, and the temp DB space out of your root. If you don't, they will default to being in your root DB space. So you want to move them out of your root DB space. Second one is your physical log. And your logs will have 30 to 50% of all writes. You want to move your physical log out of your root DB space to a separate DB space. You want to size your physical log to be about 1.25 times the size of your buffers. And the reason you want to do this is when your buffers are full, when the physical log is 75% full, you'll have to do a checkpoint. So if you have a very small physical log, it can oftentimes cause you to be doing checkpoints more often than every 5 minutes, which is the default. So look at your physical log, size it to 1.2 times the size of your buffer pool. And that will give you a good idea of what you need to do. In the webcast last month on setting up a large server, I have scripts that I gave you for creating a root DB space, a server, and then moving the physical log out, the logical logs out, the sysadmin out. So go grab that webcast, look at the scripts. There's a zip file with all those scripts in it. The logical log, you also want to move that out of the root DB space, and you want your logs to be big enough to hold 5 to 10 minutes of transactions at peak time. So look at the busiest time of your day and say, during this hour, I should have no more than maybe 6 to 12 logical logs turn over. If you have more than 12 logical logs turning over at your busiest time, your logs are too small. And you want to have enough logical logs for 4 days. And a very simple reason here, back in the old days when I had to worry about backing up to tape, I can remember this, the first time my logical log tape drive broke. It was a mess, and it was on a 4-day weekend. You want enough logical logs so that you can keep going for a 4-day weekend and not have to worry about my tape drive broke or my backup mechanism broke. You want to be able to keep going. Now, Temp Tv Space. This is where you're going to have about 50% of all your I/O. And it's very important to have at least three. More is better because Informix will use them round robin in parallel. And if you do need logged temp space, create another 1 to 3 regular DB spaces for log transactions. The only difference between these two is these get created with a -T flag to identify them as temp. These get created as a regular DB space. So they will get backed up. They will be logged. Now, if you don't do this, and the symptom I see is people saying, why am I getting all this IO to my root DB space? Well, the reason is somebody in their application wrote a begin work, create temp table. And because that's in a transaction, it can't go to a non-logged place because it's part of a transaction. So then it has to go to the root DB space if there is no logged temp DB space. So it's very important to if you have a lot of IO to the root DB space after you have moved and created temp DB spaces. That probably means you have certain, I think, badly written applications that are creating log temp tables. Excuse me. Now, indexes. The best page size for an index is 16K. And it's very simple. You can fit more of an index on a page there. And so your indexes will take fewer pages. And so my recommendation is to create a 16K DB space, move your indexes there, and then you can create a 16K buffer or indexes only. Let's go look at my example here. I do an onstat -D, type it 2 more. I've got 4 index DB spaces here. And they're all created with a 16K page size. Now you have to alter your tables and create the indexes in this, but this means I can have a separate buffer pool now just for indexes. Now, how big do you want to create your DB spaces? One question is to ask is how many rows will fit on a page with the least amount of wasted space? And this is something I like to do, is take my tables, take my row size and say, okay, how many rows are going to fit on a page? build a worksheet like this. And then how much is wasted space? How many rows are going to fit on a 4K page? How much is wasted space? Do the same for 8 and do the same for 16K. And then that will tell you for these tables what fits best. Typically, a 2K or a 4K page size is fine, except for very wide rows. And when you have rows that are very wide, you want to put them on bigger ones. We once had a project working with a client. They had basically rows that are about 15K. And they were on 2K pages. And we rebuilt that site and put everything on 16K pages. And their performance basically went 4 times faster because instead of having to read 4 pages, they could do one IO, read 1 page to get the data. So the best size for a table is going to depend on a combination of how many rows can fit on a page and how much is wasted space. If you have a row size of 1.5K, you'll get 1 row per page and half a K of wasted space. That's what you want to try and avoid. Art has a script called waste, and I have a SysMaster query script that will help you do this. Again, you want to look at partitioning large tables, any table over 2 gigs. And that's sort of my baseline of what I look at when to start partitioning tables. Now, the Informix storage pool. This is one of the new cool features. And this allows you to create a directory. It could be a cooked file. It could be a raw file that Informix can then use to automatically expand space. And there is a task that runs every night in the scheduler. So if you have the scheduler turned off, this will not work. That goes out and looks for tables that are chunks that are reaching the max size, and then we'll expand them. And it happens overnight, and then that chunk will be expanded. And it will come from the storage pool. If you mark the chunk as expandable and you didn't create a storage pool, that's okay. It will just be added to it if it can. Now, storage pools don't work when you run out of space. And like I was showing you at the beginning in Informix HQ, it's very easy to set that up. Here's the function using the sysadmin task to create a storage pool. You give it a path, give it an offset, give it a size, give it a chunk size, and give it a priority. And the priority just says if I have 3 storage pools, I'll use the ones that are 1 first, the medium second, the thirds last. And so it will then use that space. And this is the slide I showed you earlier from Informix HQ. Now, this I think is really important, is without the storage pool, you can still mark a chunk as extendable. Now, this will not work for raw spaces where you use up the whole raw space for a chunk. This will only work for cook files. And you run this function. The key thing to realize is this marks a chunk as extendable, and you have to give it the chunk number. And how do you know what the chunk number is? So I wrote this script, and this was in the scripts from the server last month on setting up a new server. But I basically go through SysMaster database, and I'm using SQL to create another SQL script. So I'm creating an SQL script here called Make My Chunks Extendable. And it's going to create a script that looks like this. And it says modify the chunk, make it extendable, and it gives it the chunk number. And I'm going to go through and get all the chunk numbers except for these DB spaces. Now you could change that. You could add specific DB spaces. You can do that. And once you've created that script, I'm then going to run that script in the sysadmin database, and it will go through and mark my DB space chunks as extendable. The way you know that a chunk is extendable is when it has this E here. This E tells it that it's extendable. So this will simplify your disk management, makes a lot of things easier. Let's see how I'm doing in time. I'm close to running out. So let me breeze through the rest of this. I think I've got about 30 more slides to go. So best practices. First of all, use symbolic links. If you're using raw devices, you have to, because this makes it much easier to move your stuff around and relink it. If you don't use symbolic links, it's much harder to move things around. And by symbolic link, I mean using the Unix ln-s command to link a raw device to a specific server. I also do that with cooked files. Second key thing is to avoid disk IO contention. And you really want to avoid bottlenecks here. Many years ago, I was at a site, they were complaining about performance, and it was very simple. I looked at their disk layout. They had like 6 disks in a server, and the first disk had the root DB space, the physical log, the logical log, and the temp DB space, all in separate DB spaces, but they're all on the same disk. That was an IO problem. And all we did was we moved the temp DB space out to a different disk, and it solved their IO problems. You want to avoid disk IO contention. Mirroring. Mirror your critical media. This way, especially if you're using RAID 5. If you're using RAID 5, I would really implore that you go mirror your information on another disk. That way the RAID system can fail. Informix will keep running using the Informix mirroring. Move the logical and physical log out of the root DB space. Again, that's to avoid the IO bottleneck that comes with that. Create 3 or more temp DB spaces. Take your high use tables. Typically when I'm doing a migration or working with a customer, I'll try and identify what are their 10 or 20 big tables that have the most IO activity. And I want to move them to their own DB space. That will speed up your disk IO performance tremendously. Separating your indexes from the data. Having a separate DB space just for indexes will allow Informix to read the index and the data in parallel at the same time. Now, let's talk about disk monitoring. And here are some examples of the Informix onstat commands to monitor your data. Onstat -d, I like to say, shows you your DB spaces and your chunks and gives you an idea of how much is free. Onstat -D shows you your IO and tells you how many pages are being read and written to different places. IOF, this is a key one. First thing is, this shows you whether you're using KAIO or not. KAIO is kernel IO, and it's much faster and much more efficient. And if you're using KAIO, you don't need extra AIO VPs for Informix. This shows that because I have 0 here, there are no KAIO threads being run. If I had KAIO turned on, that would show numbers here. The second thing is you want to look at these numbers, the reads and writes, and anything bigger than 0.01 I would look at with concern. You want to see like the 0.004 is a good number. 0.001, that's a good number. 0.000 is a great number. That means it's not being used. You want to see small numbers like that for your IO. When you see greater than 0.001, you're approaching an IO bottleneck, and you want to go find out why. On stat minus GIOV, this shows you your virtual processors and how much IO they're each doing. And this gives you I was going to say, if someone, y'all could stay on mute, I'd appreciate it. Thank you. This shows you your IO. You want to see a load spread out. I've got two AIO VPs here, and one of them is really doing all the work. That's partly because I've got not a very busy server here. And this is one of my favorite, I think this is undocumented, on stat minus GIOH. This shows you the last hour by device of IO. And it gives you an idea of the IO times in the last hour by device. So it's a very long report if you run it. But it's very handy to try and troubleshoot IO performance problems by device. You can also use the Unix Io Stat command, and that will show you from the Unix level how much IO you're doing. And even though this is from the Unix level, it's going to be by device, so it will see raw devices, and it will tell you what the IO is by raw device. Now, creating space, you want to use on space for that. And here's the syntax for that. I'm going to wrap up with a couple of little things. Using on spaces and the sysadmin command to manage DB spaces. So because we are running out of space. So you can use a sysadmin task, you can use on spaces, and I was going to go into questions, and let's look at the chat and see what's there for questions. So yeah, Art just answered the last question about extendable spaces. You can extend index DB spaces. And if the question is, can you create extent sizes for indexes? You can in the latest version. So any other questions? So a question on storage provisioning. I'm not a big fan of depending on it to do things automatically, because I think there's an element of planning you and I as DBAs need to do. And if we expect the automatic stuff to just work and it doesn't work, is when we get into bigger problems. I have seen it fail when the physical disk is really full. I've also seen it fail when it can't allocate the size that you've said, this is the size you should allocate. So I'd be very careful with the storage manager and storage pool just because of that. And even if you use it, monitor it. Good question. What is a journal file system? A journal file system is a file system that has a log. And basically when you write to that file system, it gets written to a log. And the idea is if the computer failed, it could go read that log and recover your data. And that works great for data. You don't need it for DB space. It's extra overhead. And I've actually seen it get confused because of the DB space logging. Is there a limitation on a DB chunk size? Yeah, there probably is a physical one. based on the size of your disk. But it's going to be very, very different. Art says four. Boy, you guys are answering questions faster than I can. Good question. Do we have a chunk size of 400 gig, good or bad? I'm working with another client that has 500 gig chunks. I don't think it's good because what you're doing is you're putting all your IO into one device. I think it's better to spread that out into 10 40 gig chunks than one 400 gig chunk. You'll get better IO. Remember, the thing is to spread your IO here. And the more chunks, the more flush threads you need, but the more IO and reads you can do. And if you monitor your LRUs, that should not be a problem. Your checkpoints will only be horrible if you go with the default LRU settings. Well, I'm way out of time. I apologize. This has really been good. I'm sorry for the audio here, but you know, everybody's probably working from home right now. I want to just point out a couple of things. If you're not a member, go join the International Informix User Group. It is an awesome group to be part of. The other thing I want to highlight is I used to be very active on the Informix list, and it went away. But there is a replacement for it now called the IBM Informix Community. And go join that. I'll have this link in my slide. A really good place for a lot of discussion like this. And it's a great place to go. The next webcast is April 30th, is going to be on logs. And to me, this is one of the most important things because the whole purpose of a database is to make sure you can recover and do transactions. And you want to this is what makes a database different from just a file system. And so we'll talk about that April 30th. And the other thing I want to point out, since everybody's doing stuff virtually, we do all our training. You can attend our class virtually, except it's different from a WebEx like this. We use WebEx, but it's interactive. You can stop me because we limit the size to 8 students. You can stop me and ask a question in the middle of a talk in our classes. It's very interactive. So it's not like just sitting there and watching videos. In fact, the best classes are when we leave the sound system up all day. And one time I had a class with someone in Anchorage, Alaska, someone in London. I forget which way it was. One was eating breakfast, one was eating lunch, dinner. The rest of us were at lunch, and we're all having a conversation over lunch. So a lot of fun. And with that, I'm going to say thank you all. And this was a great webcast. Really appreciate you all attending. And please sign up for the next one. You have to sign up individually for each one. Thank you all. Have a good day. Bye now.